Hello again. So yes, I encourage you to bring up questions in the chat on anything you have about Quarkus to ask, or anything that maybe that's Java related. I'm happy to answer those. So a little bit about myself, already introduced earlier, but I currently work as developer advocate at Red Hat, and earlier this year I became a Java champion, and in the mid of the year I certified myself as an architect. I like to share my experiences and my experiments at different technology events. Together with Victor Renta, we are supporting the Bucharest software craftsmanship community. In the talk today, as discussed earlier, we're going to put a lot of focus on maintainable software. So why is maintainability so important? Some of the people are kind of going away from it because they think that, well, maintainability is all about bug fixing, and having the life around only developer life around bug fixing must be boring, or must be too thrilling sometimes. And people like to start things from the beginning, but actually maintainability is about the easiness with which we can change a piece of software or a component without affecting the performance or other attributes of a system. So it's not just about bug fixing, it's also about the improving capabilities of a software system. And we want to be able to do that on our software is evolving. Our users want more and more features, right? And as a developer, well, sometimes we see that there are issues with security. So maintainability is very important, especially when it comes to fixing security vulnerabilities. And sometimes, bug fixing, that doesn't go hand in hand with fixing security vulnerabilities. You can have the most beautiful code ever and no bugs. In an ideal world, there is no bugs. But security vulnerabilities still appear in our world, and they're more often than ever nowadays. And well, last but not least is the maintainability is important for replacing functionality in our application. So not just improving a certain capability, but we want also to replace a functionality without having the pain. And back in the day, when monolithic architectures were at power, and mostly would have seen monoliths, replacing functionalities would have been something that should have been carefully planned, for example, because, well, you would have had to stop and have an outage of your entire app to put the app, to put the new functionality there. And sometimes this plan had to be really, really, really well thought. So this is why releases were not that very often. So maintainability nowadays has become something way easier because the world has embraced more and more the microservices architecture. And the reason why us as developers, as DevOps, as QA engineers are going and embracing more and more this type of architecture is because, first of all, from an operational point of view, it gives us deployment independency. And when I'm speaking about deployment independency, means that those small apps can be deployed without waiting for something. So the colleagues from operation are very happy that they don't have to wait for something, except for maybe you to deliver the code, or maybe not wait at all if you have the right pipelines. And you yourself as a coder, you don't need to wait for another colleague to develop something because, well, you don't depend on the others. Since you're deploying independently, if something goes wrong with that application, which is independent, this means that the problem is isolated. If there is something going on, it's easier to isolate the problems and not the entire platform that is based on microservices is going down. Only one part of it is probably gone and not function as expected. So it's better not to have something not perfectly functioning than not having anything at all. And thanks to Kubernetes and specific deployment techniques, nowadays you can orchestrate zero downtime. So the idea of there's going to be an outage, well, your users are not going to see that when you're using microservices because, well, thanks to these lovely things like microservices and containers, you can orchestrate things to don't see that there was a swap of code. And last but not least, if you have different workloads and maybe there are some features that are of an app that are getting used at a certain hour more intensively. You can scale those parts of your platform without affecting the rest, and it can happen. For example, think about the large shopping sites. Maybe when there's a promotion at a certain brand, that part of the website gets a little bit more intense in being used, but that can scale independently with the rest. Maybe like the frequently asked questions part is not that oftenly invoked compared to the rest of the processes there. So this is the beauty of microservices. So all in all, the architecture together with the idea of maintainability is something that should make us enjoy our work. So the world has evolved and we are now kind of having joy when doing maintenance on our systems, right? And speaking of joy, Quarkus is one of the frameworks that brings joy when it comes to coding microservices. And that's because of a few features that I personally like and I want to share with you that make my life as a coder easier. So first of all, I like the developer experience. I like the live reload. But starting with Quarkus 2.0, there's also continuous testing and dev services. And I'm going to use those today in the demo that I'm going to show to you because I want for you to see how easy it is to maintain something when you benefit of all these three. Then, when it comes to interacting with persistent stores, probably you'd have used before JPA and Hibernate because it would have been easier for you to interact with the database from your Java code. Now, Punachi is coming on top of JPA and Hibernate to help you and actually bring more value to your time. So you have some extra abstractized ways of working with JPA and Hibernate that makes your life easier. So less time for you spent on coding. Now, if you're a Spring developer, there's the good news. There's a Spring API compatibility. So in case you're more used with Spring, like I was, the thing is that coming from a Spring background, when I was looking firstly at Quarkus, I thought that it would take me so much time for me to learn the framework and to adapt to this new framework. And the surprise was that Quarkus gives this compatibility. So in my mind was like kind of an ease, thinking like, hey, if I don't know how to do something with Quarkus, maybe I can do it with Spring and still works on the same platform. So I can combine the two until I get up to speed with Quarkus. But luckily for me, this thing was like, I managed to learn Quarkus really, really fast and get to love it. And I discovered that when using Spring, Quarkus has early detection of dependency injection errors because, well, if the detection of dependency injection errors typically are done at runtime, and you see that those messages with the bean injection failure and so on, with Quarkus, you see those at compile time. So if something goes wrong, that will be stopping you and telling you something again is wrong from compile time. And last but not least, there are a lot of integration capabilities like caching, GraphQL, Linkybase for evolving your data model. So there are a lot of extensions to make your life easier. And in today's demo, because I want to give you an overview of what we're going to improve today and what we're going to maintain today, we're going to look at the personalized facts microservice that it's exposing some API. And this personalized facts microservice, probably like in real life, is consuming some information from a third-party endpoint that's not necessarily under control. And in this case, it's the cat facts API. And the cat facts API, well, I'm consuming information from this part. Sometimes when you are evolving from an legacy system to a newer system, you're not moving everything at one shot like two microservices. Maybe you can do it, but you would need probably a lot of team members working simultaneously on those microservices. And maybe you want to do it gradually. But in this case, the cat facts API offers me some information. I manipulate those information. I personalize those for later consumption. And sometimes when you're manipulating information from a third party, you're not always like wanting all the time to go and invoke this third party. You can also like have some manipulations done over those and persist those somewhere. So for the sake of our example, we're going to store some information in the facts database, which is a persistent PostgreSQL persistent store. So sometimes I'm interacting with the cat facts API, sometimes I'm interacting directly with the database, depending on the use cases. And those being said, let's code. And the first place where I want to go is actually Firefox. And let me, yeah. So in Firefox, hope that you can see it. The first place where I went to make the example for today, it's actually an evolved example because it's based, this one from today is based on Quarkus 2.3.0 release, but I also have a 1 point something example of this application. So it's a really maintained application from version 1 to version 2. And in the repo that I'm going to share with you, you're going to find a Java 11 version of it and the Java 17 version of it. And in today's demo, I'm going to use the Java 17 version of it because Java 17 is the latest long-term release. And to make this example from today, because I said I want to give to the users some services to consume, I just went to code.quarkus.io. I have set the group of my app, which is personalized facts, well, our alchemy experiments, and my artifact name is personalized facts. And with Quarkus, you're just adding what you need in terms of building your application. Now, since I already had a version of my app for version 1 point something, I just changed the version of Quarkus in the properties of my POM XML, and that was it. But if you're interested in rebuilding it, I can tell you the recipe. So the recipe is simple. For exposing your services, I added REST-EasyJXRS and REST-EasyJSON for serialization. Then for consuming the cat facts API, which is a real API, by the way, I'm using the REST client extension. But because I am a developer that also wants to interact with the API, and back in the day I used to work with Swagger a lot, I also put the Smorai open API extension that would automatically generate the API for me so that I can do some trials with my API as well while working with it. Now, in the examples that I'm going to show to you today, I'm going to use some metrics to evaluate performance in the unit tests. And also I'm going to use the Micrometer registry Prometheus all in my tests. To persist my data, I use the Hibernate ORM with Panache. And well, I'm persisting the data in a PostgreSQL database, so I need the JDD driver. So I took a PostgreSQL one. Sometimes for improving the performance of the app, you're caching some information, and you should be caching the information because doing calls to a non-managed by yourself third party or to the database, you know, it's expensive, and when you can cache, why not? And I can also evolve my API to a GraphQL API just by using annotation and Smorai GraphQL extension. So this is pretty much the story behind the app if you want to recreate it yourself with version 2.3, or you can ask me for the previous version from 1 point something. You find it in my repositories as well. It's you'll see it's the same thing. The only thing is that probably the difference in Java versions. And those being said, let's go to the IDE and see how things are looking like. And let me make this bigger here and here. So I just want to describe you my app. If you're going to download directly from code.quarkus.io the generated code, you're going to get a resource to start with and a test associated to it. But like in any maintained app, I have my own endpoint, which is the personalized facts resource endpoint. That is exposing this API to the people. And here I have the place that I'm using to consume the cat facts API, which is the facts service. And in order to inject this one, I've just annotated it with a REST client. So I'm telling to the app that this is a REST client. And if we're going to it, just to see how it looks like, this is an interface that I annotated with facts, /facts, and is just some definition of my method. So is that easy to work with consuming services with Quarkus? And probably some of you are like asking yourselves, hey, but aren't there supposed to be like an URL that you're consuming this API? Well, that's a good question. I forgot to do that, but I'm going to do that right now. And I'm just going to copy this one. This is the API. And going to my application.properties, I'm going to put my URL, and I'm going to say org.acme.experiments. It's already auto-completed. And now I have the URL here as well. So this is how you consume the service with a fact service, and you're registering this for the REST client. What I want to share with you is that sometimes this, this service, the Cat Facts API, is not very stable. So in order not to have problems with stability, I have used a few things down the road. So one thing that I can do is actually use the retry annotation. And I can say how many retries there should be for my API, and I can say make max facts for retries, and do this at the delay of 1 second. So this is what 1000 means. This is measured in milliseconds. However, you can do this for microservices and like do the retries. But if things keep on failing, and this has happened to me, and this is why you're going to find this example in the repository with at the annotations. What I did, I also add a fallback because I want to be able to give my users a response. So what I did, I just annotated with fallback and created the fact fallback class. In the fact fallback class, I don't need to define it externally. I can create it inside this interface here as well. So I'm just going to go with public static class fallback, implement fallback handler. And I need to tell you that this fallback handler should return the same result as the method that was initially returning the result. So you should be having the same type here. This is why I'm saying like a set of facts DTO. And now let's implement the handle method. And I'm just going to return something a little bit easy. I'm just going to say set of, and I'm going to say fact DTO. Come on. Okay, dot empty. And the factDTO.empty method is returning to me an empty DTO for this invocation. So when my invocation to real endpoint would fail, I would just return an empty fact so that my application doesn't have any failures. And I'm like guarding it against that. And you can do that, by the way, even for endpoints that are asynchronously giving information, like in this case here. And also you can use the timeout annotation, like to add a timeout for invoking that specific endpoint. Now that we're pretty much like safeguarded with the fact service, because, you know, bad things can happen in real life. And let's look a little bit above. Probably you've already noticed that in my application of properties, I don't have yet any database configured. And I said I want to store my information in a database, right? So one thing that I need to do is add my database configuration. And of course, I said it's going to be a PostgreSQL, but I'm just going to do these things here. And comment on these, because I don't know yet the username, password, and I don't know if I have a local host PostgreSQL database yet. And just do this and do dev. Probably I need to also create something for my production. And one thing that you can do with Quarkus when it comes to working with it, you can use profiles to separate your work. So this is going to be nice for production. And I can give this percentage dev here. And since in dev, I'm actually working and I want to get more information, I want to be able to like have the Quarkus log level set to a more finer level. So I can say here maybe info. And but I also want to, like, this is the general log level, but I want to have the log level of my application. So the way that I can work with the log level inside my application, the code I have designed, and not to have it very noisy, is like use this quarkus.log.category, and here is going to see is key. And instead of the key, I'm going to use my package, which is org.acme.experiments. And the level is not inherit, is going to be debug. So this is good for my local. Now let's move to the production part here. And while in production, I don't want to see the debug part, and I'm just going to add this info. So let's make the production. And just putting the info here. Okay. Cool. Now, since the imports in production, well, now I don't want to drop and create my production. I'm going to say none, but my imports probably are going to be different. So I can also vary the start of my application based on the profile. And I'm going to use import.dev. Now that I'm like safeguarded with all the profiles, I can go and probably start my app. And now that I am also having the log streams, I'm like, okay. So let me first make sure that I'm using Java 17 and go here and use npm Quarkus dev to start my app. So now there should be no issue in starting my app, because I also have the database, I have the service connection, and should be no problem. It's going to take a while because I'm also screen sharing. Come on. It's always taking some time when doing this. So yeah, what happens right now, as I said, on dev, I don't have yet a database configured. The reason being is because I'm using dev services, Quarkus dev services. What this does, well, it starts up for me a default PostgreSQL database in the container, because I'm using Docker here. So I didn't have to configure anything in Docker. It's just simply spinning this up for me. It doesn't use any of this information here. And it started the database simply by having the database kind stated here, which is actually really cool and useful. Now let me go to my browser and say, and I invoke this. Oh yeah, I forgot a key. So one other thing that I like about Quarkus is that if you forget keys, like config properties for your app, you can also, you have the error here. You see that you forgot something in your configuration, but you can do this and say 10. You can say update. And while this is being done, I want to show you something. Yes, you're getting it reloaded. The keyhead was appended here at the end of my file. So in case you're forgetting things like I did, you can always use this kind of trick in your application. Just use that in the dev mode, and things are going to magically be there for you in your app. So you're kind of guarded for the production. Now in production, I want to have this to 100. Let me go back and see if my app has started, and now it's telling me that, well, the endpoint that I invoked is not correct. So API fact, I should be the one invoking it. Cool. This is with the logs. So things are getting being reloaded in the back when I am like making changes to my app. Now you see here that now I said the tests are paused. So this means that the continuous testing part is being paused for my application. And now the tests are being run. When I hit R in my on my keyboard, the tests are running. And I'm just going to leave them running there because I want to make some changes to those tests, and I'm like not very impacted at the moment by them. And even if they're failing, we're going to fix them together, like in a real maintenance project. So one thing and one problem that developers have when choosing to make microservices, like how they should expose. Yeah, well, we have a small a small issue, but we're going to fix it. So one problem I have is like, hey, what kind of services should I expose, synchronous or asynchronous? Now, if you're like in that doubt, I have also done a synchronous and asynchronous one, which one is exposing the same information. I mean, it's doing the same type of query. One is synchronous and one is asynchronous. And I want to compare them. So I'll do a unit test to compare the response times of those times there. So this is my first test. Now, of course, it's probably passing because 2 is greater than 1. But let's make some assumptions. So in my tests, given 1, I'm going to make a timer to measure my requests. So the first one that I'm going to use is the timer for synchronous one. And I can also create a timer for the asynchronous part. So I'm going to use timer async, just change this one here. So 2 timers are going to actually record how my application is performing in the synchronous way and in the asynchronous way, so that I don't, so that I am not having doubts like how things are working. So the same type of request for the same amount of time and measuring how the sync time is behaving on both. And then when 2, for example, this is going to do the same thing. And of course, I need to delete these 2 from here because I don't want to have them declared 2 times. And I see that my tests, yes, they're failing, but I can say rerun. And just wait for a second. It's just going to start in 1 second and it's going to be fine. Okay. It's taking a while to run it. So you can see right now that's running compare response times, exactly my method. And my expectation when running compare response times that the synchronous time is going to be greater than the asynchronous time, because typically the exposing information asynchronous, especially when consuming something, is working differently, and it's not as good as that one. So 3 tests are failing. I really hope that the okay, 12 are failing. 1 is not passing. I'm just going to go for fixing it. This one, it's another test from another part. Just going to go for a moment here. And I'm going to say rerun. Okay. Now, so the response times, it proves that which one is performing you better. So you can use the timer to do that. Another thing that you would be interested to do to your apps is like sometimes you are seeing that in your apps, you can like have caching to like not all the time go and query things. Come on. And after doing this, well, what I can want to do is actually go to my app and see where I can add some caching. And I'm looking here that I'm seeing that maybe I can introduce some caching at the fact service level by using, let's see here, add cache result. and have here cache name. I'm going to give it like animal, sorry, fact async, and have the cache key here, which is the fact ID. And this is how I can introduce caching, just by two annotations and give a cache key. But I also have to give some limits to my cache, right? So I'm going to go to my application.properties and add my cache here. And I forgot how I called it. So I called it animal fact async. I could have given it a better name. But anyway, we're going to go with it. Fact async. And this is its initial capacity, its maximum size, and expires after writing after 60 seconds, right? So those being said, let's measure how this is going and see how we can measure the cache part. So I'll go back to the personalized facts resource test. And we have a test here called should measure cache things. And of course, I need to do a given. And I'm going to use, of course, a gauge in this case to measure my cache. So what I'm going to do, I'm going to retrieve my cache from the cache manager, and I'm just going to register gauge to contain the cache size. So always like monitor the cache size of what's going on. And then I'm going to do a few invocations to my cache. So, and see how that is going on. And then I need to assert what happened. So I can measure what happened by getting the gauge from the registry and by, getting the measurements from that gauge and checking how big is the cache size. And my assertion, let me see, because I need to give something for the assert equals here, so the test doesn't fail, is that in my cache will be 1, and I see that this value gets repeated, so just 1 at the moment, 2, 3. So by getting 3 here, I should be fine, and my test should be not failing anymore. So let me see this one. Personalized fact resource test is running the test. You see this previously, my test was saying that, yeah, well, you're having some errors, fix them. So now it runs all the tests again, and it has passed all the tests of running the personalized facts resource test, and that's great. Okay. Oh, I forgot something for my cache. The cache name, animal fact async. So this is why continuous testing is great, because it tells me what I did wrong, and it tells me the real time. Which is great. And now it's running it again, and there are no more issues. So this is with the cache. But if you want to see the response time and look at the response time of your integration test, you can also use distribution summaries to do that. So the way you can do it is by firstly creating a distribution summary in your registry. Get the size of it, and then record the request size into distribution summary, and then record an outlier to see that, well, the response time and everything is behaving as expected. So in this case, if you're like wanting to see this is behaving as expected and you have control over your endpoints, you can see that, well, you've recorded like 100 times plus 1 outlier size. So there's 101 items in your distribution summary, and the total amount of in your distribution summary is 100, and the size is 100 size plus the outlier size, which is greater. So this is another way of how you can control things with your distribution. And last but not least, I want to introduce your attention, well, because something for the configuration, because probably many of you are using it. So when your application is starting up, sometimes you want to insert things so that your database is already populated. And maybe you're using a class that is doing this initialization, or you're doing some cache initialization. It's not necessarily from an SQL you know? So what you can do in this case is, well, this is a sample of such a class annotated with a startup and application scope. So at startup, this is going to be executed. And based on the initial capacity, you insert amount of things in your app. But sometimes maybe in your unit tests, you don't want this to be run. And you can use this annotation called if build profile. And here you can say which profile you want to have. And in my case, I want to run this only for prod. So when my application is being built for prod, I want to run this thing. I don't want for this injection to be running all the time for all the other profiles of my application. So this is another way to guard yourself by long initializations. And just before jumping back to the slides, I want to show you and to invite you to look into the repo, because the surprises there are that, well, I've used records for my DTOs, and I can encourage you to use records for the DTOs if you're like thinking where I could apply records or with Java 17, well, with your DTOs. What I find it useful that to have the text blocks, which are another feature with Java 17, well, before you used to write maybe JSONs like this with escaping your strings. Well, thanks to text blocks, you're just doing this and you're having nice JSONs maybe in your tests. And last but not least, for the inheritance of the classes, I've used sealed and non-sealed class. So give it a try with Quarkus and Java 17 and see that it works, but also you can see the Java 11 version. So it's maintainable across all Java versions, it seems. Let's go back to the slides. There's some takeaways. Well, refine your log details per application profile. You can improve your application with retry, circuit breaker, and timeout. You can follow the capacity of your caches with gauges or control your endpoints by using distribution summaries, validate your endpoints by using timer, and do not forget that you can annotate with a build profile to inhibit the execution of long-running operations not required in a certain application profile. So this is all that I wanted to say. This is where you find the code in my GitHub account on personalized facts. I'm going to share it. Also, maybe you can share this in the chat. And I want to thank you for listening to me and maybe go back to the studio.